This is our paper. The title is Neurophysiological and Subjective Analysis of VR Emotion Induction Paradigm. As we can see, the effective loop of emotive machines and users consists of emotional elicitation, recognition, and behavior generation. Currently, most studies use the classic emotion induction paradigms such as watching pictures and videos or listening to music. It's a passive emotion induction in the laboratory which has a large gap with real-world scenarios. Therefore, it is difficult to elicit strong and multi-component emotions, impeding understanding of emotional processes. An ideal emotional induction paradigm would immerse subjects in a more dynamic and realistic scenario. VR is one potential medium that meets these requirements and remedies the gap between the laboratory and authentic environments. The user can be completely immersed in a virtual scenario and feel as if they are there. However, most of these studies concentrate on the emotional effects of various VR tasks or games. There have been few studies regarding VR as an eliciting material due to the minimal availability of VR-based emotion-evoking materials, especially the scarcity of using objective neurophysiological data to study emotional processing in VR systematically. Therefore, we conduct an experiment. The figure shows the overview of our framework for VR emotion induction and analysis. A is the expected emotional state and VR emotion induction materials. B is the experiment setup. We use a computer and HTC Vive to display VR videos. EEG signals were collected by ANT neural equipment. C is the subjective and neurophysiological data process and analysis. Specifically, a total of 28 participants were enlisted to watch 8 VR videos, while their SAM, IPQ scores, and EEG data were recorded simultaneously. The experiment consists of one baseline state and 8 trails. Each trail is made up of 3 parts. A fixation crosses the first 5 seconds, then the participants were assigned to watch one of 8 virtual reality videos at random. After watching each video, they were asked to rate their emotions and sense of presence using the SAM and IPQ questionnaires. The whole experiment takes about an hour to complete. The 8 VR video stimulus used in our experiment is selected from a Stanford Immersive VR Video Public Database, YouTube, and VR games from Vive's Steam platform. The figure lists 4 video samples we used. The LAHV quadrant is a Nepal earthquake aftermath. HAHV quadrant is whale encounter. LALV quadrant is a Malakahana sunrise. HALV quadrant is a real run. For the subjective scale, we adopt the 9-point SAM scale. It is a non-verbal pictorial assessment technique that directly measures the valence, arousal, and dominance associated with a person's affective response. In addition, we also record IPQ scores to measure VR user spatial presence, involvement, and sense of realness in a virtual environment. For subjective scale analysis results, Figure A shows that emotions are successfully distributed in the 3-dimensional emotional space, and the projection of VR stimuli on the AV plane is a C-shape. Figure B shows the main ratings of participants for valence, arousal, and dominance under the 4 emotion induction conditions, indicating the successful induction of the target emotion. In particular, VR has better performances for high arousal emotion, indicating the subjects experienced high intensity emotion in the VR ecological valence scenarios. Besides, many researchers believe that physiological arousal is one of the main mechanisms that produce a sense of presence. Therefore, we compare the changes in the sense of presence under high and low arousal conditions, and the results show a significant difference in SP, INV, and REAL in Figure A. In addition, we analyze the correlation between INV, REAL, and SP with arousal and find a strong linear correlation among them from Figure B. The objective neurophysiological data analysis also supports this finding. As seen from the figure, high arousal emotions are associated with increased alpha wave activity in the parietal and occipital areas compared to low arousal emotions. Meanwhile, high valence emotions stimulate beta and gamma waves in the temporal lobe area more than low valence emotions. We also conduct a hemispheric asymmetry analysis, and the results show that theta and alpha waves in prefrontal regions, beta waves in temporal regions have later rise activation only for high valence emotion. In particular, due to the high intensity emotion evoked by VR videos, we find alpha waves in occipital regions have later rise activation only for high arousal emotion. This finding extends the previous conclusions on the neurophysiology of emotional arousal. As a result, we successfully integrate EEG and VR to demonstrate that VR is more pragmatic for evoking natural feelings and beneficial for emotion research. We strongly recommend that researchers use the VR induction paradigm to acquire a more reliable explanation of affective computing. Thanks for watching.